probably the most classic example of calculus is the tangent line problem. And the tangent line problem relates to the idea of how do we figure out what the slope is on a curve as opposed to a line. Now, tangent's probably something you have two familiarities with. One is in geometry. You remember that if there was a circle, a line that was tangent to the circle meant it intersected the circle at exactly one point. And you also may recall the tangent function from trigonometry, which is actually related to that tangent line. So what does it mean for a tangent line to a curve? Well, what we're going to do is we're going to sort of generalize that idea that we talked about with a circle in geometry. And just some preliminaries here. If we have a line and it goes through some point xy and goes through another point which is x plus delta x and y plus delta y. So some change in the x value. So you have an original point, some change in the x value, and some change in the y value. Then we can find the slope of that point, or the slope of the line through those points is delta y over delta x, which is the same as that idea of y2 minus y1 and x2 minus x1. But instead of thinking of it as y2 and y1, you're thinking of this second point as simply the change from the first point. You're simply defining it in a new way. Similarly, I could say this in a more general way, which is that if there's some point P which goes through x and y, and there's some point Q, which is x and y, and some point Q, which is x plus delta x and y plus delta y, then the slope that goes through P and Q is simply the change in y divided by the change in x. And that's kind of our preliminaries. That's how we want to set this thing up. So let's take a look at an actual function. So I have a red line here, which may be difficult to see, I apologize. And we're going to call that f of x. And I have some point P that for some x value c, the point is the x value and the function at x, so f of c, right? So instead of writing y, we're going to write f of c, which is still, it's the same idea. And I have some other point q. If I move a distance of delta x, then q is c plus delta x, so that's the new x value, it's that change. And the y value is f of whatever it is at that point, right? We don't know what the value is. We just know that it's f of whatever c plus delta x is, just whatever, f of that number. So now that I have 2 points defined, what I can do is I can draw a line through them. Because any 2 points in space, you can draw a line through it. So I'm going to draw this orange line. And I know that orange line has a slope m, because that's our definition of the slope. If we look over here, we see that the delta x is defined, but we see that the delta y is just the change in the y values. Well, the y value for this one is f of c plus delta x. The y value for this one is f of c. So delta y is simply the second value minus the first value. That's kind of like that y2 minus y1. I know I said we were getting away from it, but that's the idea. It's y2 minus y1. And if you want to do x2 minus x1, you take this minus that, and the c's would cancel, so you just get delta x. So what we find is that m, which is delta y divided by delta x, can be represented by this fraction, f of c plus delta x minus f of c over x. So what can we do with this? Well, we're going to learn a lot about how to deal with this in the coming sections, but I want you to be thinking about this. I want you to think about, what does that mean? Well, if you think about, as delta x gets really close to 0, right? As that delta x slides, well then the value inside this function might, and I say might because we'll get there when we deal with limits, but if it's a function like this, as delta x gets close to 0, this becomes really close to f of c. So the top becomes really close to 0. But then on the bottom it also becomes really close to 0. So they're both scrunching in as delta x gets small, right? If my delta x is now shrunk down to here, then I have a new line, and I can just keep on sliding that. I can see that line just changing slowly. And what we're going to actually find is when we finally get there, it's going to look pretty close to that solid line, but it's going to look more like that dashed line. What you're going to find is it's going to be a tangent line. Instead of being the secant line, remember a secant line strikes twice. We're actually going to get a tangent line strikes exactly once at that point on the curve. And as we move forward in calculus, we're going to learn to think about this and get that answer exactly. But first we have to kind of build our way there. So I want you to be thinking about this tangent line problem and how we're going to get there.